In the quiet forests of Bavaria, Germany, hunters are encountering a paradox. Decades after the Chernobyl disaster, the wild boars they hunt are not becoming less radioactive. In many cases, their levels of cesium-137 contamination remain stubbornly and sometimes illegally high. While other forest dwellers, like deer, have seen their radiation levels steadily decline as expected, the boars are an anomaly. It's a radiological mystery that persists in the soil, a signal that refuses to fade, suggesting that our understanding of nuclear fallout's journey through an ecosystem has been incomplete. The key to this puzzle lies not in the air, but beneath the forest floor. Wild boars are powerful diggers, and a significant part of their diet consists of a specific subterranean delicacy, the deer truffle, genus Elaphomyces. These fungi, unlike mushrooms that fruit above ground, live their entire lives buried in the soil, forming a vast symbiotic network with tree roots. This underground web acts like a highly efficient sponge, absorbing and concentrating nutrients from the soil. Unfortunately for the boars, one of the things it concentrates exceptionally well is radioactive cesium. But even this doesn't fully explain the sustained levels. If Chernobyl was the only source, the contamination should still be fading. Recent research has uncovered a second, older ghost haunting these forests. By analyzing the isotopic signature of the cesium, scientists found not just the fallout from Chernobyl in 1986, but also a significant contribution from a different source, the atmospheric nuclear weapons testing of the 1950s and 60s. This global fallout blanketed the entire northern hemisphere with cesium-137 long before the reactor accident, creating a deep reservoir of radioactivity in the soil that complicates the entire picture. The forest soil itself is the mechanism for this long delay. It acts as a slow-moving filter. The cesium from the 1960s weapons tests has had over half a century to slowly percolate deep into the soil layers, reaching the 20 to 40 centimeter depth where deer truffles thrive. In contrast, the lighter, surface-level fallout from Chernobyl has been migrating downwards much more slowly. So, just as the weapons test cesium was beginning to decay away, the Chernobyl cesium began arriving in the truffle zone, replenishing the supply. The boars are being contaminated by two distinct waves of history, mixing in their diet. This process, where a substance becomes more concentrated inside an organism than in its environment, is called bioaccumulation. The deer truffle accumulates cesium from the soil, and then the boar accumulates it from the many truffles it eats over its lifetime. It's a powerful multiplier effect, and it doesn't necessarily stop there. If a predator, like a wolf, were to prey on these boars, the concentration would increase again, a process called biomagnification. This is the same fundamental mechanism that leads to high mercury levels in large predatory fish like tuna, where toxins build up at each step of the food chain. We often hear about the physical half-life of radioactive elements. For cesium-137, it's about 30 years. This leads to a common misconception that the danger simply halves every 3 decades. But the forest ecosystem has its own clock, the continuous cycling of cesium from the soil, into the truffles, into the boars, and eventually back into the soil when the animal dies, creates what is known as an ecological half-life. This biological loop effectively traps the contaminant, making its residence time in the ecosystem far longer than its physical properties would suggest. The forest remembers, and the boars are its living memory. The radioactive boars of Bavaria are more than a local curiosity. They are a tangible, measurable indicator of an invisible, long-term inheritance. They reveal how planetary systems, like the slow migration of particles through soil, can store and re-release the consequences of human actions decades after the fact. The fallout from the atomic age didn't just disappear. It became part of the soil, part of the fungi, and part of the food web. It's a reminder that beneath our feet, the Earth is a slow-motion ledger, keeping accounts we may have long forgotten.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.